Welcome back, everybody. In this video we're going to talk about properties of exponents. I got 7 properties here that we'll go over quickly and then do some examples showing how the properties work. First one I'm going to do is the product property. And if I have an exponential term times another exponential term, bases are the same, you would find the simplified answer by adding the exponents. Quotient, however, would use subtraction. So say I have x to the m power divided by x to the n power. The simplified answer would be x to the power of whatever m minus n is. Power of a power, let's say I have x to the m power and it's being raised to the n power. The exponents then get multiplied, x to the power of m times n. And power of a product, that's when we have separate variables, different variables. Let's say x times y, and let's say they're both being raised to the power of m. The x would then be raised to the m, and the y would also be raised to the m power. Power of a quotient works in a similar manner. Let's say I had x divided by y raised to the m power. X would be raised to the m, y would be raised to the m. Now negative exponents, let's do that one up here. X raised to the negative m. Now what happens is, think of x as a base. And if you flip the fraction of the base to flip to the reciprocal, basically in this case x goes in the denominator, we then have a positive m power. And then finally a rational exponent. Let's say we had x to the power of m over n. Well, we could define that as a radical. Put the radical sign, x to the m power, and it converts to the nth root. Keep in mind, all of these can be going back and forth. You can use these properties however you see fit. Like maybe you start on the right side of each of these equations and end up on the left. Particularly down here with rationals, you can go back and forth. Let's try some of these out and see how they work. So if we have 2m to the third power times n to the second power, and we're raising everything to the fifth, think of that 5 sort of as getting distributed to each item. And we have 2 to the 5th, m to the 15th, n to the 10th power. So power over power and the product power property are at play here. 2 to the 5th can be simplified to 32. Our final simplified answer, 32m to the 15th times n to the 10th. Again, power over power, the exponents get multiplied. Let's look at another one. Again, the 1/5, this time we have negative exponent, fraction exponent. We're going to do power over power first. The 1/5 gets distributed to the 10, p to the power of 10 times 1/5. 10 divided by 5 is 2. The r becomes -1 because -5 times 1/5 is -1. Now, we can't really leave a negative exponent, so we're just going to put that in the denominator underneath p squared, and if you wanted to, you could write it as p squared over r without writing the 1 exponent. Alright, here we're going to apply the quotient rule and power over power. First we're going to do 12, I got h to the 12th divided by h to the 4th. We will subtract those exponents, giving us h to the 8th. We then have power over power, again 8 times 3, h to the 24th. Let's look at this one here. Okay, now we're just going to rewrite this in radical notation. This is 3 to the 4/7 power. Writing that as a radical, square root, or radical symbol. 3 goes here, 3 to the 4th power. We're taking the 7th root. This could be construed as simplified. We can take 3 to the 4th, 3 times 3 times 3 times 3, which is 81. The true, I guess, simplified version of this would be the 7th root of 81. Then finally, here we have radical 2 to the 5th power, third root of radical 2 to the 5th, all of that being raised to the 1/4. We're going to convert the radical back to fraction notation, giving us 2 to the power of 5/3, and that is power of a power being raised to the 1/4. We're going to multiply the fractions to get 2 to the power of 5/12. Now if we wanted to convert back to radical notation, we could. 2 to the 5th, which would be 12th root of root 2 to the 5th, and 2 to the 5th could be written as 32. So another way to simplify this, I guess, would be the 12th root of 32. But different problems, exercises ask for different things. Just want to make sure everybody sees all the different ways. All right, these were some examples of properties of exponents. Thank you for watching.